Good evening, savages. Welcome to the Fine Savage Podcast. Let's talk some sponsors real quick before we get on to the show. Iron and Stone Strength, newest sponsor to the show. Fantastic people out of the Buffalo, New York area. They got a gym up there filled with Neanderthals lifting heavy stones and pressing weights overhead and smacking each other in the face and getting all into it. And then they make the coolest gear around. You got to check out their apparel line. Hats, t-shirts. I love the t-shirt design. Super cool. But they do sweatpants, sweatshirts, and it's all strength athletic based. You got to check these guys out. Buy some gear from them because they're good people and they make good stuff. Use the code REFINESAVAGE at checkout for 20% off at ironandstonestrength.com. Stay Classy Meats. Stay Classy Meats has the best meat on the planet. I am a huge fan. I'm all out of meat. I got to order another box. Straight out Bozeman, Montana, they are just killing it. They have elk meat and steaks and buffalo, and it's just incredible. Bison and pork and just everything you could possibly imagine. I had their chicken fillets a couple weeks ago. Even chicken they're doing right. It just tastes different. These are humanely treated, grass-fed animals. Everyone knows where these animals are coming from. They can go out and see them before they're humanely processed, and it definitely makes a difference. These guys are into this product. They want to make sure they're getting you the best quality meats available, and that's important, guys. You don't want something filled with hormones, and maybe you want something filled with hormones. That's depending on what kind of goals you have, but I wouldn't want it. I would rather have a nice, clean steak that I know no one's fucked with. You don't want meat that people have fucked with. Stay Classy Meats is here to help you. StayClassyMeats.com. Use the code SAVAGE at checkout for 10% off. Warrior CBD. Let's talk about Warrior CBD. The best way to get a hold of Warrior CBD is go through Instagram. Slide into the DMs, and Nancy, the owner, will get a hold of you herself. You can ask her questions because this is a little confusing. You're not sure what you can take, what you can't take, what you're supposed to be taking, what's best for you. But slide into her DMs and just ask questions, and then order something from them. Use the code Warrior20 off at checkout for 20% off. One of the cool things they have is CBD oil for your dog. Now, none of your dogs are getting drug tested, so it doesn't matter. Fill these dogs up with a little Warrior CBD oil. I'm telling you, people around here, they go and they get cheap stuff, and they tell me how it doesn't work. Yeah, no shit. It's not going to work. Get the real deal. Don't just shove essential oils down your dog's throat and expect it to keep it from being afraid of thunderstorms. But the Warrior CBD oil works great. Take it from me. My mother has used it with her dogs. Her dogs are complete fucking maniacs, and they do great on it. One dog's afraid of fireworks. The other one's afraid of thunderstorms. She just goes back and forth and make sure these dogs are taken care of. And it's better than drugs where the dogs are all looped up. Just give them a nice little buzz. Let them hang out in the corner and deal with the thunderstorm. It's going to be fine. So check them out. Get a hold of them on the Instagrams. Cerberus-strength.us. Cerberus-strength.us. Cerberus is the leader in strongman equipment. They are making the best wraps and straps and belts in the game. But my favorite products from these guys are the sandbags for indoor throwing. Everybody on the Highland Game circuit is always looking for a way to throw indoors during the winter, and Cerberus has got you covered. Check them out. They're making quality, heavy-duty bags that you can load to whatever weight you want and throw them indoors and not have to worry about damaging floors or anything like that. They also make great tacky and smelling salts. You got to give these guys a holler. Get on that website, Cerberus-strength.us. Use the code REFINESAVAGE10 at checkout for 10% off. Hey, they got knee and elbow sleeves too. I know you guys are all fucked up from throwing. Get a hold of them, buy some gear, and hook yourself up. Viking Coffee. Viking Coffee is the best coffee around. I am currently sipping on, what is this? I'm not sure what kind of brew this is. It isn't my old man strength brew. It's a different sample that Evan has sent me, but it tastes fantastic. I love it. VikingCoffeeCo.com. You're going to buy coffee anyhow. Like I always say, you might as well buy it from people who are supporting the show. And Evan Armstrong at Viking Coffee has supported the show from day one. He's actually been a guest, so you can go back through the podcast list. I'm not sure what episode he was, but he was on there. It was a great podcast. VikingCoffeeCo.com. Use the code VikingCoffee10 at checkout for 10% off. And finally today, Serious Steel. Serious Steel is the best group of humans in the strength and conditioning game. They are just fantastic people, led by my boy Chad Clark. I don't know if he's leading them, but he's friends with them. He's working for them. Really good dude, and everybody involved at Serious Steel has been nothing but fantastic with me. Check out their stone sleeves. I keep pushing those stone sleeves on people. It's cool because you don't have to tacky your forearms up. You don't have to cover yourself in baby oil to get the tacky off. You just cover the stone sleeve itself in tacky. When you're done, slap them together, throw them in a Ziploc bag. Next time you're ready to do stones, they're ready to go again. Check those out. But if you're also outfitting a home, garage, commercial gym, anything you need, they've got the products for you. Their bands are very inexpensive and are the best I've used. So check them out. SeriousSteel.com. Use the code SAVAGE at checkout for 10% off. On the show today, we have a little different type of interview for you. We went down to the University of Ashland, like my second home, and talked to not a hammer thrower, not a shot putter, but an anthropologist by the name of Dr. Nigel Brush. Dr. Brush is an amazing guy who deals with the Ice Age. He deals with near-Earth collisions and disasters, and basically everything I'm freaked out about, he deals with. So we went down and talked to him. He's written a couple great books, The Limitation of Scientific Truth, and I believe the other one was called The Limitation of Religious Theory. But we can talk about it in the podcast. You want to check this guy out. Super smart guy, way smarter than I was. So it was great sitting down to talk to him. And I think you're really, really going to enjoy this one. So if you dig Ice Age and the mammoth and giant sloths and cavemen and asteroids hitting the planet, this is the podcast for you, motherfuckers. I'll see you at the end. All right, we are at Ashland University with Dr. Nigel Brush. Welcome to the show.
Oh, thank you. I'm glad to be here.
I was telling you, I have a lot of connections down here at Ashland with a lot of track and field athletes. And several of them, not least of which works for me, a kid named Zach Pape, mentioned your class, and he said it was the best college class he ever took. He said it was super interesting, and so he kept telling me, you got to have him on the show. You got to have him on the show. So I'm just glad to finally get you on here.
Oh, great.
Yeah. Let's talk about what you actually do teach here at Ashland.
Okay, I teach geology, basically what's called soft rock. We have a hard rock geologist that works with igneous and metamorphic rocks, and I deal with sedimentary, which we find here in Ohio primarily. And the sedimentary rocks have the fossils in it too, so I do paleontology, looking at invertebrates in the past and things like that.
Was that something that always interested you growing up? Or?
Oh, it was, yes. Yeah. I grew up with big sandstone boulders out in the woods behind my house. They were 2 or 3 stories high. I used to climb them and build campfires on top. And
right.
So I was surrounded by rocks, I guess, from the beginning.
Yeah. Mm-hmm. What are you doing digs mostly in this area? Are you out doing digs now, or are you?
Yes, I have been for about 30 years now in Ohio. I wanted to work in England. I did get a degree in England in Southampton. Got to work at Stonehenge for about a month. It was a rescue excavation.
Explain that. What do you mean a rescue excavation?
Well, the Prince of Wales actually saw they were putting a line across the Salisbury Plain, and it was going to pass near Stonehenge. It was an underground line, and so it was going to disrupt some of the soil. And so he said that they need to have somebody come in and excavate before the diggers come in to see if there's any artifacts there. And Southampton was the closest university where I was getting my master's. And so I was one of about 6 people that worked on a rescue excavation where we excavated the pathway that the line would be coming through. And in the process, we actually went right by the Heelstone, which is where the midsummer sun rises. And we found a number of bluestone and sarsen, which is what Stonehenge is made out of, fragments. We probably took about a ton of rock. And so it was a chipping floor where they were doing the final finishing on the rocks before they erected them. And we found Roman coins and other artifacts from the Middle Ages and the Neolithic and so forth at Stonehenge. So
Wow.
apparently a lot of people would come there as tourists to see what was
I was
going
going to say
on.
Roman coins, so they were visiting as tourists even back then,
Oh,
probably
sure.
trying to figure out what was going on.
Exactly, yeah.
How interesting is that? Those megalithic structures all over the globe fascinate me, and I've gone down the rabbit hole so many different times, with different people's theories on where that stuff came from.
Oh,
And
yes.
it's so super interesting to me.
Mm-hmm.
Are you doing digs around here now?
Yeah, I worked on rock shelters for about 25 years, and these are big blocks of sandstone with overhangs where the Native Americans could camp under. And so I surveyed about a 200 square mile area in Coshocton and Holmes County, where there's a lot of these sandstone outcrops. And we identified about 300 sites that had been utilized based on flint flakes and pieces of bone and things like that underneath them. And we excavated 30 of them over that time period. They went from 12,000 years ago up until contact at 1700. So we had the full range of artifacts over Ohio prehistory.
So how many years ago?
12,000 was the earliest.
12,000.
And that's dating back to the Ice Age.
Right.
Yeah.
So at 12,000, what civilization are we dealing with at that point?
We call them the Paleo-Indians. We, for a long time, thought they were the first peoples in the Americas coming across the Bering Land Bridge from Siberia. Now we know there's a pre-Clovis culture as well.
So that was the prevailing theory for a lot of time, was the Clovis first model, right?
Exactly, yes.
Okay. And now that's kind of, there's only very few people still hanging on to that model, right?
Yes, I was at a conference in Santa Fe a few years ago, and it was on Paleo-Indians, and it's pretty much the consensus of almost all the scholars there that there were occupations going back earlier than Clovis. And so we're back to somewhere around 20,000 probably.
Wow.
For the earliest peoples coming in.
Wow, that's amazing. And is there evidence that these people didn't just come across the Bering Land Bridge, or are they coming from islands in the Pacific? Are they, coming up the coast from South America? Was there different places that they were coming in, or?
There's several theories about that. It looks like about probably 99% of the Native Americans came from Siberia, Asia, and so forth, across the Bering Land Bridge. So that was the great pathway. The problem was when they got to Alaska, most of Canada was covered with ice, and so you had a big barrier that they really couldn't move on into the ice-free areas in the United States and on into South America. So there, for a while, we thought there was an ice corridor that opened up. There was a major glacier over the Rocky Mountains called the Cordilleran, and there was another one over Hudson Bay, and those two ice sheets eventually coalesced together, and so there's a solid barrier across Canada. The idea was that eventually an ice-free corridor opened up near the end of the Ice Age, and so they could move down through that corridor from Alaska into the U.S. But we found that the dating of that is wrong, that we actually have people in Central and South America well before that corridor opened up.
And I had read that. That's why I was trying to figure out how exactly did they get there, where they came from.
Well, now we think that they were probably using ice-free islands along the Pacific coast, and perhaps even the Pacific coast itself. Part of it might have been ice-free. We found some caves on the mainland that have bear bones and such, dating from the time of the glacial maximum. So we think that there may be an edge along the Pacific where there wasn't any ice, and certainly the islands didn't have ice.
Right.
So they're probably using boats to island hop and maybe work their way along the coast. That's the way they got around the ice.
And that's a fairly new theory too, that they were actually seafaring at that point, right? That they could island hop?
Oh, not necessarily. Humans occupied Australia at about 50,000 years ago, and there was never any land bridges connecting Australia with Southeast Asia. So they had to have some kind of boats to get across there at 50,000. So
yeah.
At 20,000, they certainly should have had access to that technology.
At 50,000 years, are we dealing exclusively with humans as we know them today?
Not necessarily. Well, the people that entered Australia were Homo sapiens, but there were still some Neanderthals hanging around Europe until about 30,000 years ago.
Okay.
And now we're finding some other genetic markers that suggest there might have been other groups in addition to the Neanderthals and Homo sapiens that were coexisting, at least for a while, in that early period.
And the Denisovans, is that how I say that?
Yeah, that's one of the groups.
It seemed to me like there was, at that point, for lack of a better term, it was more of it was almost like a Lord of the Rings type situation where you had all these different...
Oh, it does seem like that.
Yeah.
It was a surprise that we thought Homo sapiens was the only one, and now it looks like there might have been several groups. And genetics has really helped us see that, although we did find what's called the Hobbit in Indonesia a few years ago.
That was the other thing I was going to ask about.
Right, and that form looks like it may be descended from Homo erectus, which dates back 300,000 years, clear back to 1.8 million. And the ones in Indonesia are much younger than that, but it's surprising to see those connections as far as the cranial morphology goes between these sort of small hominins in Indonesia and the Homo erectus populations. So that's speculation, but...
It's amazing to me that, I guess growing up, maybe I just didn't pay attention well enough, but growing up, it was always this seemingly straight line of progression, from these ape-like creatures all the way up to Homo sapiens. But it seemed like they're finding branches all over the place and people coexisting. And
exactly, that there's multiple Homo 2 million years ago living in Africa. And it gets more complicated. It's, rather than a ladder, it's more like a bush or a tree where there's multiple lines that are interbreeding back and forth. So it's getting very complicated. I know when I was in graduate school at Ohio State studying anthropology, we had, maybe 6 or 7 hominids, and now we've got over 20. It seems like every year or two we have to add another one to the line.
Right. And it's not exactly like a long period of time that you're finding these things.
Exactly.
It just seems like things keep getting older too. We keep pushing dates back that tools were being used, or people were using boats and things like that. And it just keeps getting further and further back.
Right. Yeah, we've had this naive idea that everybody was primitive up until Homo sapiens came along, and now we're finding a depth of culture that keeps going back further and further. And that's the name of the game in archaeology or in geology, is to find the oldest living life forms or hominins and whatever. And,
it's interesting to me that we as Homo sapiens have been around for 250,000 years. Is that
200,000 for certain? Now it looks like there may be a site in, I believe it's Morocco, where we have some forms that may be almost 300,000.
Wow. That
isn't widely accepted yet, but that's on the horizon now that we're talking about that.
Yeah. Do you have any? I'm interested in the fact that we've been around for 200 to 300,000 years now, and in the last, few thousand years, we've gone from reading and writing all the way to sending probes to Mars.
Right.
But for 200, maybe closer to 300,000 years, we weren't really doing much of anything, it seems. Or are we dealing with rises and falls? It's interesting to me that we had hundreds of thousands of years of very limited progress all the way for these last few thousand years we've exploded.
Mm-hmm. Yeah, that is interesting. It's the last 10,000 years, and that is when the Ice Age, or at least the last glacial stage, comes to an end. The Ice Age isn't over, obviously, but we're in an interglacial now that began about 10,000 years ago. And
is that the end of the Younger Dryas? Is that?
It's in that time frame.
Okay.
Actually, the Ice Age was beginning to end about 15,000 years ago, and then at 12,009 there was a return to full glacial conditions for over 1,000 years, and we're still debating exactly what happened there.
I've heard about the theory that there was a comet impact at that time that might have sent us back in.
Exactly, and I was rather angry when I first heard about that theory, because I teach a class on discovering the Ice Age and also one on asteroids, comets, and catastrophism. So I felt that if anybody should make that connection, it should have been me.
Right. You're right up my alley too, because I'm fascinated with the Ice Age, but I am strangely fascinated and terrified that we are about to get hit by a comet at any time.
Yeah, I heard that too. I heard the other day that more people in America are thinking that NASA should focus on trying to find possible impactors rather than going to Mars or whatever.
Well, you'd think that's the legitimate up close and personal threat at the moment.
Exactly.
I heard Neil deGrasse Tyson say that we were at least a decade away from any kind of technology that could actually deflect a meteorite or a comet from hitting us.
Right. We've certainly theoretically talked about various ways to do it, but I don't know if we actually can get it in line if we suddenly should see one
right
on the horizon.
So what are your thoughts on the comet impact, or the proposed comet impact that sent us back there?
Well, I got the book right away after that theory came out, and used it in one of my classes. Mm-hmm. And turns out they were kind of all over the place, kind of throwing a lot of theories at the wall, and a lot of the scientific data didn't support it. My primary argument against the impact at 12,900 years ago was that my class on asteroids and comets, I talk about the Cretaceous impact 66 million years ago. And we started out with just a few lines of evidence. Now we have probably a couple dozen lines of evidence for that impact. And that's 66 million years ago.
Yeah, right.
And there's almost no evidence at 12,009 for an impact. The book I was talking about, one of their suggestions was it came down in Canada on the ice sheet.
So that's what I had always heard.
Yeah, so it made a big impact in the ice, but then the ice melted and the evidence is gone. But there still should have been a lot more evidences for that impact if it was that close in time to us.
Right.
And so that's one of the reasons I've been very skeptical about it, having read the book and so forth. I understand recently they found a fairly large crater in Greenland, and they're trying to date that, and I think it may date to that time period. So
wow.
Turns out there may be some evidence after all. But,
yeah. But that was another theory that was very heavily fought against, right?
The one with the dinosaurs?
Yeah.
Oh, yeah, that went on for over a decade before they sort of reached consensus, and that was because they found an impact crater in the Yucatan.
Okay,
that was sort of the smoking gun that validated the theory because it dated to that time period, and you had all the evidences for an impact, melt glass, and so forth.
So that's basically what we were talking about a little bit before the podcast, was that science is so flexible. We think of some things as scientific fact, and then 2 years later everything changes, and
right,
everything's different.
And that's what makes science exciting. You're not just dealing with a set body of data. You just memorize it, and that's all you ever have to do again. You just keep repeating what you know. But the fun of science is that we're always making new discoveries and having to revamp what we think we know about the structure of the world and so forth.
Yeah. And it has, I guess, to be a good scientist and a good researcher and a professional, you have to be flexible enough to change with the times and not be stuck in your dogma from 20 years ago that you may have been teaching for 20 years, and now it's all changed.
Oh, exactly. If you don't keep up to date, then you become a dinosaur yourself academically. Sure. In archaeology, there's a classic example of that with Vera Gordon-Childe. He was the most famous European archaeologist of the first half of the 20th century, and he had mastered a number of languages so he could work in the museums across Europe and into the Near East. And so he reconstructed archaeology back 10,000, 12,000 years ago, and was able to tie all these cultures together based on artifacts and similarities of pottery and things like that. And so he wrote probably almost a dozen books, and he was the authority on European prehistory. And he thought that it radiated out of the Near East. That he wrote a book called it was on the dawn, I believe, and it was about the light of the civilization in the Near East illuminated barbarian Europe and all this.
Okay.
And all that fell apart with the development of radiocarbon dating. And Colin Renfrew, who became the most famous archaeologist in the second half of the 20th century, wrote a book on the radiocarbon revolution and showed that a lot of Childe's reconstructions were wrong.
Yeah.
And Childe, he was getting older at this time, but he returned to his native Australia, took a taxi out to this high cliff laid his glasses down along the side of the road and jumped.
Yeah.
And he left a letter saying that he didn't want to hinder the development of archaeology, that everybody would be looking to his theories and so forth. And so he thought he would just sort of step out of the picture.
Wow, there's a he could have made a statement.
Yes, he could have said I'm wrong. But
Right. There's a little bit easier ways of doing that.
So there's other scientists that are much more successful that do recognize that they may not have the whole truth, and they're willing to, as you say, sort of roll with the punches and try to keep abreast of what's happening. There was a guy by the name of Griffin. He was an archaeologist at the University of Michigan, and he did that. I heard him lecture when he was probably in his 80s, and still very much up to date, with where we were going and so forth. He was always open to new things, and that's the path I wanted to take rather than a child's path.
You got to avoid suicide at all costs.
Yes, exactly. So don't put too many eggs in that basket, I guess.
What exactly are you teaching? You're teaching. What are you teaching here at Ashland? I mean, what are the classes?
I have 4 core classes that are for non-majors. One is archaeology and human antiquity. I slipped that one in. This is supposed to be a geology program, but it's sort of related. And archaeologists deal with rocks, stone tools, and geomorphical landforms where people are living and so forth. Then discovering the Ice Age, asteroids, comets, and catastrophism, and also a class on natural disasters focusing on volcanoes and earthquakes. So those are my core classes for non-majors. In the majors classes, I teach physical geology, historical geology, geomorphology, and sedimentology, and stratigraphy.
And that's if you're going to become a geologist. That's
those are the 4 of the major classes.
Yeah, that's the ones you mentioned for non-majors all of them sound right up my alley. I want to audit them.
That's exactly what I taught them when I came here to Ashland. They were revamping the whole program, especially the classes that were everyone had to take. And they said, could you offer some classes? I said, sure. There's a lot of things I'm interested in and like to teach, and so that's what I've been doing for almost 20 years.
That's fantastic.
Yeah.
Speaking of comets, am I correct in saying that we're getting close? Twice a year we go through this Taurid asteroid stream? Is that?
The Taurid.
Yeah,
that's one. There's actually 7 we talk about in our class. There's more than that, but there's 7 well-known ones that happen throughout the year. And each time these occur, we're passing through the tail of a comet. So we're actually in the orbital path of the comet. Fortunately, the comet is not where the Earth is at that time.
Right.
Could be somewhere in the future. But as the comet approaches the sun, it heats up and it leaves a debris trail of dust and gas and so forth. And so when the Earth passes through that debris trail, then we have these particles falling through the atmosphere, call them falling stars, but they're just small little meteorites that are burning up. And so we have these infalls that...
So if you're seeing shooting stars or falling stars, that's what you're seeing?
Yeah, you're just seeing little bits of rock and so forth that are burning up as they come through the atmosphere.
Right.
Some of the bigger ones might make it to Earth, but most of the stuff gets burned up before it hits the Earth.
That's amazing to me. And I heard, I can't remember who said it, but they talked about passing through the meteor stream is akin to crossing a busy road at 2 o'clock in the morning blindfolded, because 99 times out of 100, it's not going to be a problem. But the one time you step wrong...
Right, there could be some bigger rocks out there.
Right.
And I think the Taurid is known for that often in October you have some rather large fireballs that we see. And it's kind of around the time of Halloween and so forth, so everybody gets excited about it. But yeah, there are some bigger pieces in that stream that you have to worry a little bit about.
Yeah, and it'd be nice if we had some kind of plan in place instead of maybe we spent less time invading foreign lands and dealing with. There's other ways to spend that money,
right?
Instead of a global killer. So I read your first book, and I've got it right here, and I actually had you sign it for me. Limitations of Scientific Truth, and it was super interesting to me. And you say right in the beginning that one of the questions you get asked a lot is, how do you deal with being a religious person and a scientist, and that it's too broad a subject to discuss, quickly.
Right.
But what I really enjoyed about the book, number one, it was it was written for an ape like me to understand. It wasn't, I'm sure it wasn't written that way, but it wasn't something that was totally over my head. And
well, good. I hoped it would be.
Yeah, it was very interesting. And but maybe talk a little bit about that, how those two halves work together. And I thought we talked a little bit before about how often science changes and how often theories change, and that there is still room for both spirituality and science in the same place.
Right. Well, I became interested in theology in high school, I guess. I actually, at the time, I was interested in outdoors and hunting, and I was going to run off to Canada and have a hunting camp or something. And,
right.
Wasn't that into school, basically. And I dropped out eventually in my junior year. And oddly, I went home and got a bunch of books out of the library and started reading what I wanted to read.
Right.
So I wasn't against education. It just I didn't see the value of it at the time. And so I got a job in a factory for 6 months, and then I saw the value of an education.
Yes, that'll do it to you.
Yeah, it did. But a part of that searching was what is my purpose in life, and I got interested in religion and decided to go to college to study for the ministry. And so I went back to high school and finished up, and I went to Bible College in Cincinnati. And it was while I was there that I realized that one of the main arguments against faith in the scriptures and so forth was what science was saying with regard to the age of the earth and evolution and things like that. And so once I graduated with my degree in Bible, I decided to go into science to see what scientists had to say. I thought maybe that religious people didn't know very much about science, and scientists didn't know very much about religion.
It's a good way to look at it, for sure.
Yeah, so I thought I would train myself in both, and maybe I could see a harmony between the two. And so I went to Ohio State in anthropology because that's sort of the hotbed of evolution. And from there I went to Southampton, England, got a master's degree in archaeology, and then UCLA with a doctorate in anthropology. And during that time I was trying to find linkages in between what the scriptures were saying and what science was saying, and I found a number of them, which you would expect if the world was created by God and the scriptures are God's revelation, that the two revelations ought to be in harmony. But the problem was that a lot of the bridges I was building between religion and science kept falling apart. And I came to realize that the reason was that science kept changing. So that's how I came to write a book on the limitations of scientific truth, that why can't we arrive at absolute truth? What are the limitations? And I based it not on what theologians were saying, but what scientists themselves were saying and philosophers of science. So that's my main source of information on those limitations. And so I hope that would be an avenue where Christians then wouldn't be so threatened by science, that once they realized its limitations, that it might change, the next day if we make a new discovery.
Right.
That maybe they'd be more willing to get involved with it. But unfortunately, that wasn't the case. That it seems like a lot of Christians have really come to hate science and reject it totally, or at least the parts that are convenient to reject.
Yeah.
They still go to doctors and things like that, but
yeah.
More and more aspects of science is being rejected by many very conservative religious people, even to the point of vaccinations and so forth.
Yeah.
We're beginning to see that problem developing with measles and so forth. I realized that if I'd known exactly where our society was going with regard to science, especially religious people, maybe I should have focused on the limitations of theological truth rather than that of scientific truth,
Yeah.
because they already didn't believe scientific truth, and I just gave them some more ammunition, I guess. So eventually I did write this book on the limitations of theological truth, and
which is the next one, the sequel,
right.
Maybe.
Sequel, exactly.
Yeah.
And my argument is that because both theology and science are human disciplines, the weakness of both is the human limitations. And of course, from a scriptural standpoint, we're fallen individuals, we're sinful. And I think there's three basic areas that provide weaknesses, and one is human ignorance. We don't have all the facts, and this is why science keeps changing. And secondly, the facts we do have, sometimes we misinterpret them. And thirdly, because of our bias, we often actually distort the facts to fit our preconceived theories.
Yeah.
And so I think both scientists and theologians have that problem, and I can cite many examples in science, and in this second book I've cited a number of examples in theology. I know as a student, when I started Bible college and I was doing student ministries at churches, I would often find that what I was saying on Sunday would be negated the next week in class. I'd learn something new and have to retract what I'd said.
Yeah.
And so I realized that my own theology was changing, and hopefully for the better, as I was in college to study theology. But I talk about that in my book, and then I talk about the disciples and how their understanding of the Messiah, their theology was actually changing throughout the ministry of Christ. And even though they were Jewish and had been expecting the Messiah, yet when they actually were face to face with the Messiah, a lot of their understanding of who he was supposed to be and what he was supposed to be able to do, they didn't understand it. And so Christ had to keep leading them into a better understanding of the Scriptures. And certainly the Pharisees had major problems with understanding the Messiah. They were supposed to be the religious academics of their time. And so I devote several chapters in my book to the mistakes the Pharisees made, one concerning the birthplace of Christ, and another concerning his authority over the Sabbath, his authority to go to sinners. They often said, well, you shouldn't be associating with sinners, and yet that was his mission to come to the earth and save the lost. And finally, his divinity, that it very clearly states in some of the Old Testament prophecies that he would be called the Son of God, the Most High, the Everlasting Father. And yet when Christ made those claims, the Pharisees said, oh, this is blasphemy. And why didn't they understand those scriptures, that this is who the Messiah would be? He would actually be God incarnate. And so, you see these mistakes over and over and over again that theologians are making, just like scientists.
Even from the earliest part of this.
Yeah, and you can. I also do some work in church history then, and talk about the different councils and the divisions of the church over time, and of course it was Christ's desire that all Christians would be of one mind and one heart, and yet we splintered into three major divisions and multiple denominations, and so there's something wrong, on our part as far as understanding the Scriptures and following them in our theology, and so. It's not the Scripture I'm attacking, but it's our interpretations that are less than could be desired.
Well, there's always one common problem with any doctrine is the people. There are people promoting it or interpreting it, so we have these biases and ignorance. And
sure. So I see one in the Scriptures that talks about God reveals himself through his creation. King David talks about that. Paul talks about that. And so as a Christian, I see that God reveals himself through both the Scriptures and through the world he's created. Mm-hmm. And of course, the world he's created is what scientists study. So we should be able to see, the handiwork of God in nature as we study it. And I found that to be true. But I think that all science and all theology is a mixture of truths, half-truths, and falsehoods. And so it's very hard to get these things to match together when you've got these mixtures. I think if they ever do arrive at absolute truth, scientists and theologians, then they will be in harmony. But I don't have much hope for that, I guess, in this present world.
Yeah. And there's so much division created through politics and jealousies and all these different human emotions that keep us apart. So you don't like a certain political candidate because he's promoting global warming or something, and the right is pushing Christians to do certain things and think certain ways for their own purposes too. So
I think that was a major mistake when the churches got involved with politics.
Yeah.
Politics is a dirty business, and you can't get involved with it without
getting your hands dirty.
Getting your hands dirty, and that's exactly what's happened in recent years, I think. And
they find ways to twist it, and
right.
And even I can't remember who it was. It was Marco Rubio in Florida. I remember when he was running for president. One of the first questions they asked him. Now, we have all these problems going on in the world and in our country and things we need to deal with. And one of the first questions they asked him was, do you really believe the world is 6,000 years old? And so now he's stuck between a rock and the hard place. Does he offend, the far Christian right, or does he say maybe what he's really thinking that it isn't, but they just put him right in a corner where he had to make a choice.
Right.
But
and it's a political choice,
right.
How many people are going to vote for me if I say this or vice versa.
Yeah, he was for sure stuck there. But, I don't even know, is that still a way of thinking with a lot of Christians that...
Oh, very much.
Yeah.
I think they've actually the conservative side of the church is really focused on that now. I know when I was in college, there was a middle ground. We had the sort of the fundamentalist on the far right that they believed a certain thing. If you didn't believe it, you're going to hell, basically. Yeah. And there were the liberals on the other side, the extreme, and they were didn't have really any solid beliefs. It seemed like in some ways that they were open to a lot of different interpretations, and in between were the evangelicals that tried to keep a balance between those two extremes, and that center ground has collapsed in the last few decades. Yeah. And so I find myself rather isolated trying to hold this middle ground.
Sure.
Because the scientists don't appreciate my religious views, and religious people don't appreciate my scientific views.
Well, it's like trying to be in middle ground in politics. I have beliefs on both sides of the aisle, but
sure,
there's certainly no one towing that line at the political level, for sure.
Right.
You're on an island by yourself.
Yeah, and that's a pathway that humans often follow as far as thinking that it's easier to be at one extreme or the other rather than try to weigh both sides.
Yeah. You got to get on a team. Got to get on that team.
Exactly. Yeah. It's like when we're dating. That you're in love with this person. They're the best person in the world. You break up, and it's easier to hate them rather than stay friends.
Yeah. Yeah.
So it's just nice and clean that way. And so I think that's sort of typical of human history, that we fluctuate between these opposites, and truth lies somewhere in between in many cases.
Right. Have you done much work with any of the animals that would have been present in this area, like Ice Age type?
Yeah, I've excavated 2 mastodons.
Have you?
I'd like to find some other animals. On my bucket list is a saber-toothed cat and more.
Did we have those here in Ohio?
Probably. We haven't found one yet.
Right.
That's why it's on my bucket list.
Yeah.
I think the closest we found them are in Tennessee, but there's no reason they couldn't be here in Ohio.
Sure.
Unlike big animals like mastodons and mammoths, they typically don't get stuck in bogs and trapped, where we find a lot of those big animals. So we'd have to find caves, probably where they're denning and things, where the bones would be preserved. If they're just lying about on the countryside, they tend to get eroded away.
Right. And
we do have caves over in western Ohio, so there's a possibility where we have limestone that we may eventually find some, but I haven't got a chance to do that yet.
Right, but it's on the bucket list.
It's on the bucket list, yeah.
Yeah, those animals fascinate me. The short-faced bear and the saber-toothed tiger and things like that. And just they weren't gone that long ago. It's not like these were dinosaurs millions of years ago. These were thousands of years ago, which doesn't seem like that long ago.
Yeah, and the bones aren't even petrified yet. They're not turned to stone. They're still bone. And actually, Thomas Jefferson, working out of Bone Lick, which is just south of Kentucky, had some individuals go there to collect bones for him, and they were so fresh that he actually thought maybe mammoths and mastodons were still alive, perhaps out west. And so when Lewis and Clark went out looking for the Northwest Passage, he asked them specifically to look for these animals to see if there were some still there.
Yeah.
And it was a reasonable expectation, given the recency of the materials.
And we're looking to maybe be able to bring one back now. I saw they're trying to.
That's the idea. I don't know.
There was and I get my brain doesn't work, so I get fragments of these stories. Is it true that there were a time when the pyramids were built, that we still had mastodons in some remote island.
Yes, Wrangel Island,
Wrangel
in
Island,
the Arctic Sea.
yeah.
There were some mammoths. They were smaller because they had gotten smaller being on an island and limited food resources and such. But yeah, they were still living there. So that's one of the arguments for humans being the primary agent that wiped out a lot of the Ice Age megafauna.
Right.
Is that where there weren't any humans, these animals survived well into the present interglacial period.
So you're not a proponent of that theory that we overhunted these animals into extinction?
I'm very much a proponent of that.
Oh, you are? Okay.
Yeah, exactly. That, it's where humans are present that these animals disappear. It's those isolated areas such as...
Because they were on an island, right?
Yeah.
Okay.
Yeah. And there's a whole bunch of evidence for that, actually. I know Dan Fisher at the University of Michigan, looking at tusk, you have growth rings on the tusk. You can tell the seasons when the animal died. In the spring and summer, when there's a lot of food, they have a thicker ring, and in the winter, when there's less food, there's a thin ring, just like tree rings. But you can also see spacing of births also with the tusk. Females, when they get pregnant, have a thin ring even in summer because a lot of the food is going to nurture the baby and so forth. But looking at those rings, we don't see any evidence of starvation near the end of the Ice Age. That's one of the theories, that the animals lost habitat and so they starved to death. And the rings are doing just fine, the thick rings in the spring and summer and thin rings. So there's certainly no evidence of that. We do have evidence that wherever humans arrive in a new area, there's a mass extinction that occurs.
Right.
We see this in Australia, we see it in the Hawaiian Islands, we see it in New Zealand. And so it's not surprising that when humans arrive in North America, again, there's a major extinction event. Eventually, humans have to develop a balance with the animals, otherwise they kill them all off, then they're out of luck, they're out of food. And so when we came here as Europeans to America, the Native Americans had that balance, and there was deer and turkey all over the place, even though Paleo-Indians had been here for 20,000 years. But in that initial invasion, a lot of the big megafauna did get wiped out, and we think it was because of human hunting activity.
Yeah.
In my Ice Age class, we actually have 6 theories that we talk about, and the one with by far the greatest amount of evidence is the overkill hypothesis.
Okay.
Yeah.
Speaking of when Europeans came over, do you have any idea what it would have looked like when they got here? Were we dealing with small numbers of Native Americans, or was the continent, South and North America, the continents just packed with civilization? Or
well, there were certainly cultures spread across the Americas in all kinds of different environments where people had adapted to those, from deserts to woodlands to the Arctic. But the population densities were pretty low. When Daniel Boone came into Kentucky, I think the story is that he was there for several months before he saw a living person.
Oh, wow.
And it was in the spring when a small Native American hunting group passed through. So if you're living by hunting and gathering, you can't have real dense populations. It just doesn't work.
Sure.
So we actually think that perhaps the development of agriculture at 10,000 years ago was the result of population densities increasing because of coastal flooding. As the ice melted, the sea levels came up, we lost a lot of the coastal regions, people had to move inland. And so this is why at about 10,000 you begin to see the development of agriculture around the world. And it may be population densities became too high for hunting and gathering to be viable any longer.
Right.
At least that's one of the popular theories that
Sure.
I like.
Which is the same reason why we don't, why hunting for your food nowadays isn't a viable option for everybody.
Right.
It's nice that I have a freezer full of deer meat, but not everyone can live that lifestyle. There's just not enough deer.
No, there aren't. You're not going to feed 7 billion people now or more. It's not going to happen.
Yeah, that's it would be nice, but that's not the way it works. So, do you do dinosaurs too? Is that part of the teaching here at the school?
Well, certainly with regard to the asteroid impact. I'm interested in mass extinction events. There's been 5 big ones in the last 500 million years, and one of the major problems in science now is to figure out what was the agent that caused those. Is it multiple agents, or is there one single killing agent? And for a long time now, there's been 2 contenders for mass killers. One is certainly asteroid impacts, but the other are flood basalts. And these are massive outpourings of basaltic lava that periodically occur and cover significant areas of the landmass.
Wasn't there and again, here we go with my brain, that I only get half the story. Was there a volcano that killed the vast majority of human population at one time? Took us down to a few thousand people?
That's the theory, because there seems to be a genetic bottleneck, and humans begin leaving Africa, Homo sapiens begin leaving Africa about 100,000 years ago, and by 70,000 or so they had already reached Indonesia, and there was a major eruption there of a volcano at about 75,000 years ago. And so underneath the ash we do find occasionally artifacts, human artifacts from that time period. So we think that maybe it was such a violent eruption, a supervolcano basically, that it may have really reduced human populations, probably because of climatic change, maybe short term, but if it puts enough dust and sulfur dioxide in the air, it causes global cooling for several years, and obviously they didn't have grocery stores and things that you have a few years without food, and you're going to have a lot of people dying.
Yeah, well, I think if you went a few days without electricity or food nowadays, it might be even worse. The hunter-gatherers might have been best suited to handle these things, as opposed to us soft humans living in our beautiful offices and going to the grocery store.
Yeah, I agree.
Yeah.
But these flood basalts, the greatest extinction of all was in the Permian period. And there's a huge flood basalt happened in Siberia at that time. And one of the primary damaging effects of that is a massive amount of carbon dioxide going into the atmosphere. So we think it caused global warming, probably raising the temperature about 5 degrees. That's one theory. And that 5-degree rise then caused the permafrost to begin to melt, which released then more carbon dioxide and methane, and also methane hydrates that are in the shallow ocean surrounding the continents. Where organic material washes out into the ocean from rivers, it gets buried on the ocean floor, and then it rots and it releases methane. But it's so cold on the ocean floor that methane is trapped as an ice. It's called a methane hydrate. But if you warm the ocean waters enough, then that methane hydrate melts and begins to come up, and it's a much more powerful gas than CO2. So a book by Peter Ward talks about this, that there's a 5-degree rise because of the CO2 from the volcanism, and then another 5-degree rise because of the permafrost and the methane hydrates melting, and that 10-degree rise then caused an extinction of about 95% of life on Earth.
Wow.
So a pretty nasty scenario, and it got our attention because that's what we're trying to keep from happening today with regard to the temperature rising more than a few degrees. That we were trying to hold it at 2 degrees Celsius, and we're moving towards that very rapidly. And there comes a point where it gets warm enough that then these other natural feedback mechanisms kick in, and it's out of our control at that point.
Right.
And that's what we don't want to happen. So that's why we're talking about trying to keep the temperature from rising more than a couple degrees Celsius.
Are you? Do you believe that it's the global warming we're going through now is man-made? Is it natural? Is it a combination of both? I mean, that's the big question, right?
Yeah, well, we get into that in Discovering the Ice Age, because Discovering the Ice Age is all about this climatic shift, what caused it. And so we talk about 3 climatic cycles in my class. I try to get my students to memorize all 3 of these. I'm still having trouble with that. But the biggest climatic fluctuation is between what's called hothouse Earth and icebox Earth. And this is over a 100 million year cycle. It's a really big cycle, and it's being driven by plate tectonics. As the continents move, periodically some of the continents are moved over the poles, and because of the limited sunlight, that's where you begin to get glaciers forming, obviously in Antarctica and Greenland and so forth. Another way that plate tectonics can do it is moving continents over the equator, oddly enough. You'd think that'd be just the opposite.
Right.
But you have at the equator between 0 and 30 degrees, you have the trade winds that are blowing west, both north and south of the equator.
Okay.
And those trade winds get the currents moving in that direction as well, the surface waters. So you have these big currents that are moving westward. And if there's no continents on the equator, near the equator, then you just have this warm water going around and around, and it tends to mitigate colder temperatures further north and under those conditions, you have a hothouse Earth, where there's actually no ice on the Earth, and so sea level is higher.
Super high sea levels.
Yeah, but if you block that flow, then the currents are directed north or south towards the poles, and that's an icebox configuration. We have that today. Africa, South America, Indonesia are all sitting on the equator.
Mm-hmm.
So we've got some continents over the poles or near the poles. We've got some on the equator. And lastly, when you have a lot of mountain building where you form a supercontinent, the collision, of course, raises mountains. And as those mountains weather, it pulls carbon dioxide out of the atmosphere, dumps it into the rivers as bicarbonate and carbonate, carries it into the oceans where it's extracted by shelled organisms that make limestone. So it's a way to remove the greenhouse gas, especially CO2, from the atmosphere, dump it into the lithosphere, into the rocks, and that also will cause a change in the climate then when that happens. So there's three mechanisms by which plate tectonics can cause either warming or cooling.
Mm-hmm.
And so we're in an ice age configuration today that Europe, Asia, and Greenland, and North America are all sort of clustered around the North Pole.
Right.
And some of the portions of all those continents are within the Arctic Circle. And of course, Antarctica is over the South Pole. We have three continents over the equator, and we have quite a few mountains, including the Himalayas, because of the collision of India and Asia. And so this ice age began about 2.5 million years ago. Typically, ice ages last tens of millions of years, so it looks like we're just getting into this ice age. It's not. It was wishful thinking when we thought it ended 10,000 years ago. It's just we're in one of those slighter fluctuations in interglacial period. So that's one of the major climatic cycles. And so from that standpoint, we are in a cold phase right now rather than a warm phase. And we'll probably stay in it for another 10, 20, 30 million years. But there's a second phase, much shorter, called glacial interglacial cycles. And these only appear when you're in an icebox Earth, where you have ice on the Earth. And so you have fluctuations of the ice advancing and retreating during an icebox Earth. And that cycle is driven by the orbit of the Earth around the Sun. And so we have this 100,000-year cycle that we go from almost a cyclical orbit around the Sun. And when we're in a cyclical orbit, the climate is not that much different between summer and winter, because we're the same distance. The tilt, of course, will affect whether we're in summer or winter, but there's still a more mild climate year-round. When we move into a more elliptic orbit, then we spend more time away from the sun. That's the configuration of an ice age.
Okay.
And right now we're still moving toward a cyclic orbit, so that's the good news.
Yeah.
That probably a few more thousand years yet before we begin to move back into that elliptical orbit. But that's what drives this secondary climatic cycle, and so that's why we're in an interglacial today. So we are in a warm phase with regard to that climatic cycle, and we would expect it to continue getting warmer. The last interglacial, 125,000 years ago, the sea level was 20 feet higher than it is at present.
That's 20 feet. I don't think people understand what that means for coastal areas.
Exactly. There go the Florida Keys,
right,
and many of the coastal cities.
Miami, New Orleans, they're all gone, right?
Right. So if this interglacial is anything like the last one, then we might expect that eventually it's going to get warm enough that we're going to lose part of the Greenland ice sheet, and sea level is going to come up at least 20 feet. But that's without thinking about humanly induced global warming. And there's still a third cycle, a 1,500-year cycle, that is much more limited, only maybe a 2 to 4 degree fluctuation. These are called bond events, and we're in a warm phase of the bond event. So you see it gets complicated.
Sure, there's so many variables.
Yeah, in the big picture, we're in the cold phase. We're definitely in an ice age, and we're going to stay there. But in the middle cycle, the interglacial glacial cycle, we're in a warm phase. We expect it to get warmer. And in the bond event, we're in a warmer phase that began about 1850. This is a 1,500-year cycle, and it's driven by fluctuations in solar energy. That it's almost like the sun is a beating heart, and as it pulses, it releases a little bit more energy, and then it contracts. And so we have fairly good evidence based on cosmogenic isotopes that are produced in the upper atmosphere of these energetic and non-energetic cycles of the sun. those isotopes fall into the sediment on the seafloor, and we can recover them, and we can see this spacing about every 1,500 years.
Okay.
So we've got these two natural cycles that are coding for warm, and one natural cycle that's coding long-term for
Right.
cold. And then you add in human activity, and then all bets are off as far as we're going.
So there's too many variables to even. But we're not helping. We're not helping anything.
No, you're already in two warming phases,
Right.
and you're adding massive amounts of greenhouse gas to the
Right.
atmosphere. You know, normally volcanoes produce a few 100 million tons of CO2 every year, and much of that CO2, of course, is taken out of the atmosphere by plants in photosynthesis. So there typically is a balance where there's neither a net loss or net gain of CO2. But because we're burning fossil fuels, we're putting in about 32 billion tons every year from coal, oil, natural gas. So that's far in excess of what the natural cycle is. And plus we're cutting down a lot of the rainforest that would absorb some of that. We're polluting the seas, and so the plants in the ocean, you know, are dying in some areas because of red tides. And so we're just making it even worse that these buffering agents, we're removing those as well as dumping large amounts of CO2 in the atmosphere. So that's the bad news, that it's going to get a lot hotter probably than in the last interglacial. Because of all the CO2 that we're dumping in.
And there's not much. Again, you know, we turn this into a political football instead of actually doing something that's going to help.
Right.
You know.
Yeah, and why should the environment be a political football? I mean,
right. Everyone wants clean water and be able to breathe, and
yeah, it's just like national defense. Is that a political football that one side says no, we shouldn't have any defense, and the other say no, we should? I mean, we at least agree on that, and I think we should agree on this, because this is also something that threatens our existence as a nation or even as a world. And I just don't understand that one political party is taking a position that there is no global warming and the other that there is. And it just doesn't make any sense.
I think with the 24-hour news cycle and these 30-second interviews, quote unquote, where they have these people just screaming at each other, it makes it difficult, because then again you're forced to pick a side, and with very little information you're just getting this 30 seconds to a minute argument going on. I think long form conversations like this, where you can actually sit down and listen to people who have knowledge like yourself, and put that knowledge out there, and then you can say, oh, well, that does make sense, you know, I can understand that now. And it was very interesting. We went up to Chicago last month, and we saw Brian Cox talk, and Brian Cox is a cosmologist. And I was reading your book at the time, and it was very interesting to me that here's this scientist who is talking about the birth of the universe and black holes, and it was an incredible show. It was amazing because it was a Thursday night in Chicago, and he had a sold-out show. So 1,000 people showed up in this theater to hear this guy talk for 3 hours on cosmology, which gave me new hope for the universe, you know, that we're okay. But I was in the middle of reading your book, and at the end of it, he said, none of what I've talked about today is a talk against creationism or a god or spirituality, because just like you had said, there's too many factors involved, and we don't know what happened before this, and this is as far out as we can see. So it was interesting that there was another scientist who was saying, you can't discount any of this, it's all out there somewhere. And I think personally, when I look at people who are either extremely religious or atheists, I find them almost arrogant, that you are absolutely sure that there's no God and this is all just done through science, or on the other side, that you understand God so perfectly that you know the truth yourself. And to me, when I look at either one of them, I go, how could you discount there being some form of supreme being? And on this side, how could you possibly understand a supreme being and what that would entail and what that looks like? And but it was interesting that was reading your book at the exact same time he was talking about these things, and I think your book is very important for people to look at from both sides of the spectrum.
Oh, thank you. It's been my quest, because it really bothered me, that division between science and religion, and that's sort of been a lifelong goal of mine to try to understand it. And these books are sort of my answer to that. I don't know if it's the correct answer, but it's an attempt to...
It's an answer that makes sense, though, you know?
Right.
And
I guess that's the best we can do of what we have.
Right.
Try to make sense of things.
Yeah.
Yeah, but I think humility is really important in both scientists and theologians, that you don't know it all, and you may be mistaken, and you ought to recognize that. And
I haven't read the second one, but through the first one, I think that is a great summation of the book itself, is that we don't know everything, and we need to be a little bit more humble, and we'll learn as we go.
Yeah, I try to encourage our students that I think that there basically are three basic approaches to finding truth that humans have developed, and one is religion, and one is science, and one is philosophy. And I can sort of dump everything into the three categories. There may be other categories, but those three work for me.
Yeah.
And each one has a different methodology. Obviously, that scientists are working with empirical evidence, and certainly religious people aren't. They're looking at supernatural evidence, that divine revelation is key to most religions. And philosophy, of course, is logical thought, and there's all categories that you can actually sit in a dark room and think about what the purpose of life is and so forth, and each one has their contribution. So I think it's, as college students, it's like you're putting your hand behind your back and tying it behind your back if you reject any of the three, that you should be looking at all of them and trying to develop an understanding of the world as best you can.
That's what they're here for, right?
Exactly, yeah.
Learn. Well, I want to thank you. So folks, Nigel Brush, the books are The Limitations of Scientific Truth, which is the one I've read, and The Limitations of Theological Truth. And like I said, I read the first one. It was fantastic, and I look forward to reading the second one. And I want to thank you for having us down here today. This was great for me, and especially those people that kept telling me that I had to get you on the show. So I didn't know anything about you, other than I had probably 3 or 4 people say you got to get a hold of them. So
well, thank you, Mark. I appreciate the opportunity to talk about these issues. I love these things and love to talk about it.
Great. Well, we'll do it again sometime, I'm sure.
Okay.
All right. This has been The Refined Savage.